Hi there. Prepare to be captivated by an unparalleled journey into the heart of creating a Kubernetes high-availability cluster within the vibrant VMs of our Proxmox server. First things first, picture this. A dynamic GitHub project showcasing 3 mighty Ansible playbooks that will redefine how you perceive cluster creation. Hold on to your excitement as we introduce the powerhouse, our very own Semaphore VM server nestled within the Proxmox server, orchestrating the symphony of our cluster-building expedition. 1. Utilizing a GitHub project where we've crafted 3 Ansible playbooks. 2. Employing a Semaphore VM server operating within our Proxmox server. 3. Demonstrating the creation of task templates within our Semaphore VM. 4. Executing the playbooks from the templates on our Semaphore VM server. 5. Finally, we will be executing the shell scripts generated by our Ansible playbooks on the Kubernetes node VM servers. 6. What sets our Kubernetes cluster apart is that nodes aren't identified by IP addresses, but by fully qualified domain names of the VMs, such as hippo.kozao.com, the primary master node, giraffe.kozao.com, a second master node server, and zebra.kozao.com, the first worker node. Now, without further ado, allow me to introduce you to our Semaphore and Kubernetes expert, Nico. Please note that Nico has a Dodecanese accent, but he speaks the Queen's English fluently.
Thank you, Josh. Hi there. Today we have a double barrel lesson. We are going to be creating a Kubernetes K3S cluster using Ansible playbooks running from Semaphore in our Proxmox server. We will create VMs, and in these VMs we will be creating the nodes for a full high availability Kubernetes K3S production cluster. This lesson serves 2 purposes. First, it shows how we can create the Ansible playbooks as projects inside Semaphore, which we will then run to create our Kubernetes cluster. And secondly, it serves to show how you can create a Kubernetes high availability cluster, or even a standard cluster with 1 master node and a different number of worker nodes. The information for this is available on our blog page. The URL to the blog page is given down below. We're also going to provide a link to this video on this page, and that is because you are going to clone our project. We have created a GitHub project which we are going to run in this Semaphore server. In the previous video, we will give a link below. We showed you how to create a VM and install the Semaphore server on that in your Proxmox server. If you haven't watched that video, we suggest that you look at the link down below to that video and watch that video first so that you can see how to create the Semaphore VM server in your Proxmox server. After doing that, then you can proceed to watch this video. We also suggest that you open this page and do the exercise with us. In order to save time, we are only going to create 3 playbooks, 1 for the primary master node, 1 for a second master node, 1 for a worker node. We suggest that you use this as an exercise to create the playbooks for additional master nodes. You will want an additional master node for a minimum 3 master nodes for a high availability cluster, and or you want to also create 3 or more worker nodes. We are only going to show you how to create 1 the onus is on you to use this as an exercise to create the others. This procedure is fully documented in our blog page that we are looking now. And with that, we will continue. We are going to be creating 3 Ansible playbooks that will allow us to create the Kubernetes K3S cluster using Ansible in our Proxmox home lab. We provide a link to this blog page down below. Please open it. Try to follow us by doing this on your own Proxmox home lab. We assume that you have watched the previous video. We have a link below to that where we showed you how to create a Semaphore VM running in your Proxmox home lab. Please have a look at that if you haven't done that before. Now let's start this lesson. So I have already logged into my Semaphore server, as you can see here, and I give all the instructions. The only thing you have to do is change that to the user and the IP address of your Semaphore server in your Proxmox home lab. So I'm there. Then you need to run the sudo su command or sudo su dash command to make your user root, like I have done there. Once you've done that, then go to the OPT folder. We are going to create 2 folders inside there. First, a folder called Semaphore, and then a folder called K3S. So let's go into the Semaphore folder after creating them. And in here, we are going to clone our GitHub project. You can get this project by opening this link here. If you click on that, it will take you to this page here in our GitHub repository. And there you'll find that you can get this command. To save you time, I've already copied it in there. So just run this command, paste. I'm not going to run this now, as I have already run this in the past while testing my video. And then you will get this. Now what you need to do is go into this folder, cd create -la, and you need to delete the .git folder. You need to delete that. rm-rf.git. I'm not going to run that command now. And then after you've done that, you need to say git init. I'm also not going to run that. And then you need to say git add dot. I'm also not going to run that. And then you need to say git commit -m initial commit. I'm also not going to run that, but these are the commands you need to run. And then after you've done that, depending on which repository you are using, if you are using GitLab or GitHub or any other repository, you will create an empty repository on those servers, and they will provide you with the instructions to be able to pull this into their repository so that you can have this in your repository. Please don't modify this. And we do provide a link there where we show where the instructions are. So if anybody finds it in your repository, this is an open source project. So please keep the original README there so that people can be able to find these instructions so that they can use this project. or delete this project when you're finished. But you're welcome to keep it. It's open source. After doing that, you then need to run start Semaphore. Now, I've already done that over here. I have run start Semaphore. So Semaphore is busy running on mine on port 3000. And then this is the link to the IP address of my Proxmox VM and the port. So you will just change this link to be what your IP address is for your Semaphore server. And then you will come up with this page here. I'm just going to expand the screen. At this point in time, we are done with this, so I can minimize the screen. I will now be working from the Proxmox VM. I've already logged in, but if you haven't logged in, when you created this server, the Semaphore server, you would have created a user. In our video, we showed you how to create that, and we used the username and password as admin and admin. But you're welcome to do what you need to do on your side. And we also provide a link below for that instruction in case you haven't created a Semaphore VM in your Proxmox server. Then please watch that video first. After having done the creation of the repository in your GitHub or GitLab or whatever Git repository you are using, now we want to use that. So the first thing we are going to do now is we are going to create a user. After logging into the server using this link with the IP address of the VM you created in Proxmox for your Semaphore server, you would then log in, and as I mentioned earlier, when we created our Proxmox Semaphore VM, in our case, we use the user as Nico and the user ID to log in as admin and password admin. So that's what you will type in if you were on our installation. So depending on what you did, you would then authenticate. After doing that, you will then come into this screen. Now, the first thing we want to do is to create users. This is an optional step. So if you click on team, you can go here and you can add additional members. I'm not going to do that. I'm happy with my user, but that's what you would do. The next step is to create a key store. Now, I've given an example here of Robota, but you can create a key store. This is going to hold the password and the URL for connecting to your GitLab or GitHub or Git repository. So that we do over here. I've created one here. This is my project, and I've just called it -key. So that's for this project. And you do that by clicking this button and you give it a name and you select the type. So mine was login with password, and in there I put in the login ID and the password and the key name as well. I'm not going to create it. So that's what you will find here for this. That is the first thing you need. You need to have this key so that you can connect to your repository when running this Ansible application. After doing that, the next thing is we want to create an environment. So we go here, we click on environment, and you will notice I've created an environment Nico, and also to follow with what we did in our example in this page, also created an environment called Robota. So this is what you would do. You would give it an environment name and you would copy values in there. So let's see what I did on mine. This is now what you need to do. This is the Ansible SSH user. In other words, when you were SSHing to this server, your user was Nico. When I created my Semaphore server, remember I mentioned I had a user Nico. I created a Semaphore login. The login user was admin and the login password was admin as well. So this is what you would now add to yours. After creating the environment, we can now create the repository. So click on repositories. I created my repository with the name of the project. And this here is the URL to my project, which I've already given you a link below. But this is to the main project, not to the .git file. And my user is master. You can use whatever user you have created for your repository, and then the link to the key. So it's done like this. Create a repository called Robota. You need to give it a URL to your Git repository, the branch, whatever you have, main. I use master as I've been a developer for the last 25 years, and I got used to creating master branches, and I find it very difficult to work with main branches. It's just, I'm an old-timer, so that's the reason I use master. It's nothing to do with anything else but habit. And then select the key. This was the key that we created. And then you hit the create button. I'm not going to do that. I've already got one. There it is. Now that we've done that, and we've created our repository, now we can go and create the inventory. So if you open our project on the internet, you will see a folder called Playbooks, and you will find 3 playbooks here. We are going to start with the second one. This one creates the primary master node. So that's the name of the Ansible playbook that you need. So let's go here and create the inventory. If I go to inventory, and I've created the inventory called Robota. So I need to, and here I need to specify the path to the file. So let's copy this. And then you would say create. Let's see what we've done here. We can learn from my example. So in my case, because I have used OPT Semaphore and I created my project in that folder there, you see. So what you can do is the same thing. That original Semaphore folder, you can clone your project there. Well, your project will sit there. So this is the path, and then this is the project name, and here's the file. Now notice that there is a folder in there called inventory.ini. So if we go here and we look in inventories, there it is. So it's the inventory. You're basically creating a link to this file here. So that's exactly what we are doing here. That is for the inventory. I'm going to cancel that. Now the inventory file, if I open it up in the GitLab or in my GitHub, this provides me with all the servers. You see, this is the FQDN, or what they refer to as the fully qualified domain name. So that's there. And then the IP address of the server. As you can see, I'm not using IP addresses in the script. This is a unique way of creating Kubernetes K3S clusters. No one else has done it before. This is unique to our YouTube channel. We want the name of the nodes to be the fully qualified domain names and not the IP addresses as everyone else does. So we can recognize in the node what the server is. And you'll see I've grouped them. This is primary master node, and here's other master nodes. You can see I have 2 here, and this is worker nodes, and here I have 4 worker nodes. So I've basically got 7 nodes in this cluster if I create all of these. So that was the inventory, and now we come to the interesting part. When you work with Ansible, you manually run from the command prompt or from the terminal. When you use Semaphore, we now can run these from the browser. And this is now the interesting part of creating the Kubernetes cluster this way. Let's open it. And now we go to templates. And we say create a new template. You click on this button. And now you provide all the information in here. Now, to save time, I'm going to close this. And then I'm going to click on this link here. And when I click this button, this is the information that you need to put when you create your template. So you give it a name. This name here is the same as your Ansible playbook, except that it doesn't have the .yml added to it. So that's the name, and the description is the same. And then here we have the playbook. So this is the path to your playbook. So playbooks, and then it's a relative path. So relative to playbooks, and then here is the name. Now my inventory, I had created an inventory called Robota. So that's where I have the details of the servers, that's in there. And then here is the repository I had created before. In the environment earlier, I created an environment called Nico. And then in the vault password, this was also when I created the key store with the password in the key store. So that all that information that we created, this is where we use it. And now I want to pass additional values in a form to this playbook. When I run it, it should ask me to provide these values. Now the way it works is you click this button and you give this a name, XX, and the title XX. Don't worry about description. This should be a string, and you click required. So that's how we create these. I'm not going to create a new one, so I hit cancel. And we do this for all the required parameters that we want to pass. So there they are. We decided that we were not going to make our Ansible playbooks prompt the user for a root user and root password. For security reasons, we decided we would use a normal user and a normal password. So step number 4, you can ignore, unless you want to make the changes yourself. Now, in order to continue, we had to start our Semaphore server. And in the future, when you are creating new projects, you can start straight away from this step here, step number 5. So we've already done that, and we've started the Semaphore. So I'm going to skip this step, but this is what you would do. This will allow us now to be able to run our playbooks. What you need to do is open your browser to your Semaphore VM login. So this, in my case, is the URL I will use. I've already logged in, so if I click this, it will take me here. I will now run the playbook for creating the primary master node. So let's run this template. We click on what you do is you go to your task templates and then you select the template you want. So I would select primary master and then refresh the browser to take you to the top. Now you can, in your case, you will hit run. In my case, I will hit rerun, as I have been testing this. As I mentioned earlier, we do not want to use the root password and the root user. So I'm just using a normal user and password. This would make the system a little bit more secure or less risky. You see now, there's a field here called token, K3S token. When I run this, I will eventually be creating a Kubernetes cluster. It has now run successfully. So what I can do now is go to the Proxmox server, open the primary master node in the console, and I'm going to log in as root. I have already done that. So you would say sudo su-. So I'm now root. And then I will find the file in my home folder for that user. So cd/home, and the user is Nikem. And then there we will see what was created, ls-la. And there's the shell script, first master node. Now that I'm a user in root, and you'll notice that this file was created executable. This was all done by the Ansible script. It generated the file, it made the file executable, and then it SCP copied it to this server in this folder. So all I have to do is run this script, /1 tab. This will now go ahead, connect to the GitHub of K3S, and it will create us a Kubernetes master node. I will pause the video because this takes a few minutes. And now that it's run, I can run a Kubernetes command, kube control get nodes. And you can see I have a master node created. Now if you go back to my instructions, you will see that there's a command you need to run after you've created the master node. So here is the command. It says there, after running the playbooks. Now this is the first playbook. Remember, we do not run the others until we've run this. So here's the command we want. We want to run this command, cat var lib rancher K3S server node token. I suggest you open this in a terminal. So let us SSH to the primary master node. SSH nick m at 10.154.2.80. Yes, sudo su dash. We want to go back to the home folder, so cd/home ls-la, and there's the script we've just run. Now we need to copy that command from the browser. Paste it, run it. Let's expand the terminal. So we will need this so that we can run the other Ansible playbooks. And with that, let's go back to the Semaphore server. We can now close this, and we can now go to the next template, the other master, and rerun. But this time we are going to put the token here. And now we rerun. This will generate the shell script with the correct token inside it. And it's done that. And we go back to templates, and we want to do the same for the worker node. And we change that to what we found. And we rerun. Now let's have a look and see what was created. If we go back to our documentation now, you will see that when we ran the Semaphore playbooks locally, we got this. Let's go in there. We recommend that you install tree. So this is sudo apt install tree -y. It will do an automatic install, but this has to be run on the Semaphore server. So I'm going to create another tab, and let's just get the IP address of the Semaphore server from the Proxmox. You see, what I do is I give the VMs a name, and then the last 2 digits is part of the IP address. So I now know that this is 10.154.2.95. So if I go back here now, 10.154.2.95. I'm there, and then go back to our instructions. So you want to run this command, sudo apt install tree. I've already run it, so I'm not going to do that. But you will see that Semaphore creates as a temp folder. Let's copy this. Copy and paste. I need to be root, so let's do a sudo su dash. I've now logged in as root. Now I should be able to run this command again. And you see there, it's created us repositories. So every time we run this project, it's creating us a repository. I think it has to do with changes. When we commit changes to our repository, it sort of keeps a history of these. So let's go into the last one, cd/temp Semaphore repository 4. Sorry, I typed CE. This should be CD. And now let's run tree. And this is what it's done. I have the whole structure of my Ansible project is found here. You see there's a folder called inventories. Inside there's a production inventory, and then there's the inventory. So if I have other environments, I could have inventory development, inventory production, whatever we use, inventory QA. And then here's my playbooks. These are the playbooks, they are there. I even have a README file here, and I even have a template. You see, this whole project is built on this NodeMaker template. Depending on what parameters we pass to that, we were to create a primary master node or another master node or a worker node. depending on the parameters. And we only used one script to do that. So this thing, this template, it's a J2 file, also known as a Ginger file. So that's what we got. You see now, I did not want to use the root password, but I did create this folder. So if we go back to the home folder, cd/home nick m ls-la. Oh, I'm now not in the VM, so this is not applicable. You have to be in the VM. So I suppose I could do it in the VM here. ls-la. And I can now copy that file. Because I'm root, I can copy cp 1 tab /opt/K3S. I created that folder. And the reason I do that is because when you're finished with your Kubernetes cluster, then you will want to delete the nodes. So I give you the instructions here. To delete the master node, you need to first run a kill all to stop all the nodes from running. Then you run the K3S uninstall. And this will delete the master node on that VM. Whether it's the primary master node or any of the other master nodes, this command is what you use to delete master nodes. And then to delete worker nodes, you also run the kill all command so that it will stop the nodes running on that VM, in other words, the worker node. And then you run this command to delete the agent. You see, in Kubernetes, we talk about a worker and the master. But in K3S, they talk about a server and the agent. So the agent is in K3S what a worker node is in Kubernetes. It's just the semantics. So these are the commands you would run to delete your cluster. And because we've saved the files in the K3S folder, we can then rerun the commands again. The only thing we will need to do is to change the token like we did this time. We would need to do that again. So you can run the same procedure again on the other nodes. I'm not going to repeat the same process for the other nodes because the worker node and the other master nodes is identical to this, and it just takes a lot of time to run that. So the exercise for you to do now is to create let's go back here. Let's go back to dashboard templates. You see, I've only created you one master node. I've called it other master node. You could actually call it second master node and third master node. So this way, and you use the same code that you have for this one. You copy, let's open this and edit it. So you copy everything you've got here, from there to there. You copy everything that you've got from there to there. And you also copy all of these. And then when you run this, I'm going to cancel this. And then when you run this, you copy these values onto a piece of paper. Now, remember when you cloned the project, let's go back to the Kubernetes project. It's over here. So this is the URL that we provided you to access this project. But when you copied this project, you'll notice that we created you playbooks. We created you 3 playbooks. You will need to add to your Git repository the additional playbooks for the second and third workers and for the third master node. And remember, with high availability clusters, Kubernetes with Kubernetes high availability clusters, it has to be an odd number of nodes. So it's 1, 3, 5, and this is not Fibonacci numbers, this is odd numbers. The reason for that is when your primary master node dies, one of the other two master nodes will fight to become the next primary master node. And that's the reason why you need an odd number of master nodes, not an even number. And with that, we have completed this video. Please do the exercises and put comments below. Tell us what issues you had. Thank you. And with that, I hand you back to Josh.
Thanks for joining our informative journey. In this presentation, you've delved into HA, Kubernetes, and Semaphore, its graphical user interface. Here's a brief summary of our coverage. Our journey into K3S streamlined cluster creation, exploring the K3S lightweight production-grade Kubernetes using Ansible Playbooks and Semaphore's remarkable performance, workload agility, and UI ease, redefining cluster management. In this video, we learned how to 1. Utilize a GitHub project, where we crafted 3 Ansible playbooks. 2. Employ a Semaphore VM server, operating within our Proxmox Server. 3. Demonstrate the creation of task templates within our Semaphore VM. 4. Execute the playbooks from the templates on our Semaphore VM server. 5. Finally, we executed the shell scripts generated by our Ansible playbooks on the Kubernetes node VM servers. 6. What set our Kubernetes cluster apart was that nodes weren't identified by IP addresses, but by fully qualified domain names of the VMs. Today's insights unlock the potential of Kubernetes K3S, enriching your containerized app management journey. If valuable, subscribe for our latest Kubernetes tutorials, ensuring you're updated with technology advancements. Enthusiasts keen on exploring K3S, join us as Patreon supporters. Gain access to specialized training, expand expertise, and support channel growth. Patreon backers get privileged access to ensure staying ahead in Kubernetes cluster's evolving landscape. Your support is invaluable. Expect more insightful content. Stay curious, keep exploring, and leverage Kubernetes K3S's extraordinary capabilities in your container orchestration journey. Thank you for being part of our vibrant community.